each presenter gets better and better, so we're setting the bar high. Dan Miller, come up, Lieutenant Colonel Abraham, and Dominic Metzger for a panel discussion. Please, the floor is yours.
Good morning.
Where's the slide clicker?
How's everybody doing? All right, great. My name is Lieutenant Colonel Courtney Abraham. I am a 20-year veteran of the U.S. Army. I am here with SAP as part of the Secretary of Defense Executive Fellowship. So I'll be with the organization for about a year. I'm a part of the panel today, and I'll do my best to moderate and progress the questions and allow you to hear from the experts. So we have Dominic and Dan. A little bit about how the panel will work. I have a couple of questions that I'll tee up for them, and then I'll let them progress the conversation along. Here are our topics that we have up, and as you can see, each of these 4 topics are in line with the SecDef's priorities of readiness, strengthening alliances, as well as business reform. And all the questions I have are teed up in line with his priorities. First up, we have Dominic. Just a little bit about him. He's a managing director at Westenacker Consulting Base out of New York. Started with SAP in 2007. Has worked many different roles from program manager, consulting, SAP supply chain. And for the past 4 years, Dominic has been leading different consulting practices at Westenacker and has been deeply involved in customer transformation programs, transportation management, as well as SAP supply chain planning solutions. Next, we have Dan Miller. He's been with SAP for 14 years, currently serving as a solutions architect in SAP's American Supply Chain Center of Excellence. Dan's 23-year experience in manufacturing and information technology. He's also a graduate of Annapolis. Go Army.
Go Navy.
He's a retired naval reservist, and he served our country very well. He served in a variety of billets there, both active and reserve. So we'll drive right on into our topics here, and I'll get it teed up, starting with additive distributed manufacturing and how it'll change the supply chain. So 3D printing technology has advanced, enabling faster, cheaper production of more complex parts. Dan, how could this be deployed to simplify spare parts and forecasting?
What I'm seeing in industry on this area here is we take advantage of 3D parts is moving away from the prototyping printing of parts out to actual productive parts. Whether they're productive parts used in production lines or productive parts for spare parts, we're seeing the opportunity here to stop trying to forecast the long tail of parts out there and actually then simplify your process by forecasting the materials I need to print those parts. The other side of it, what it does, instead of now forecasting the unforecastable, I can also provide service at a faster basis to troops that are deployed or aircraft that need to be put back in the ground or put back in the air, they're stuck on the ground, by having a part that's printed closer to the source of demand rather than back at a supply point somewhere in CONUS, and now I need to move it halfway around the world. And we're seeing that also for commercial suppliers where they're looking at how can I print that part at a UPS logistics center, drop it right on the plane, and it's at the customer the next day. The thing that we look at DoD too is an assessment of those parts of are those parts actually viable to be printed? And when you do that, the engineers at one of the Whirlpool companies are looking at this. They've actually said some of these parts, maybe we don't build them to the same standard as the OEM part because it's more important to our end user to get that machine up and running. And I think that concept has great applicability inside DoD because in some cases that tank commander may not care if the part lasts 500 cycles if he needs to get that tank back out in the field. And so maybe a part that I could deliver within the next 3 days that'll last me for 2 or 3 weeks is more important than a perfect part that won't get there for 4 months. And so there's a lot of concepts here and how you shift your forecasting process and simplify it and what you actually provide to the field. Some of this requires significant engineering input and a change in the procurement policies that go along with it.
Dominic, did you have a view?
Thank you very much. So, the whole topic of 3D printing is obviously an amazing innovation that companies, especially in the commercial space, try to adopt. And in our opinion, it solves a key challenge, which is you need a rapid in a rapid time, you need a part where it really matters. And it solves that problem in a very elegant way. It solves it by actually manufacturing the part as close to the source of demand as possible. And I think that is the new, let's say, the new way of looking at this problem. Yeah. What we have been doing a lot, especially in the commercial space, is, which is a very mature reality for a lot of commercial companies, is being very strong in optimizing their inventories and where they store inventories across a complex supply chain. So I think that can also lead us a little bit into our second topic in how you ensure that at the right point you have the right inventories. So the way how we like to look at this problem, and I like to describe it a little bit in almost in a pendulum. On the one extreme, you run into a risk when you look at store or having your inventory levels. You run into the risk of having too much inventory or simply not the right inventory. Right? The big risk that brings, or the challenge is, first of all, you bind an enormous amount of capital in inventory that might not actually be the right one, and inventory gets obsolete, right? Inventory has a life cycle. Inventory might or might not be needed. So that's on the one extreme of the pendulum. On the other extreme is, obviously, if you don't have enough inventory, you run into extreme issues in your service levels. So what we learned is especially some of the, especially looking at some of the Department of Defense units, where service levels are in the 70% mark, our goal in the commercial space is at least a 90% SLA service level of being able to supply the right part at the right time, at the right place. Yeah? So the challenge, or the managing this challenge, is really being centered, being balanced, having the right inventories, and that obviously also allows you to tremendously reduce your cost to move inventory and react much faster.
All right, Dan, how does inventory optimization for commercial enterprises relate to the perspective from DoD?
So one of the things I'm seeing in commercial enterprises is long-lived equipment. So one of our customers out there, Komatsu Underground Mining, actually has used this tool and this algorithms to reduce their inventories by 25%. And their machines are actually sitting in a mine for about 25 to 35 years. So they have a lot of long-lived equipment sitting out there that they've got to support for a very long time, and they don't want to stock parts forever that may never get used. And so how do you sit there and figure out what truly is the demand variability, what is the right place to put things, what lot size do I need to make them in? And they're using all these factors to figure out where I'm going to put my inventory so that I get the right service level to the customer to keep these really long-lived machines in place, balancing that with the lot size that they're building. That's a very similar problem to DoD. This is not commercial packaged goods where I'm producing 100,000 widgets a day and the demand goes away 2 years from now because I've obsoleted the iPhone and now we give you the new iPhone. And all you get at the Apple store is go buy a new one. So this is the same kind of thing we're seeing in industry. The problem that it is, and a big change, is the procurement processes need to change to support this. You have to be able to go out to your suppliers and get smaller lot sizes. You have to do technologies like additive and distributed manufacturing that will shorten the lead times on this procurement to be able to move things faster through it. And so this process is not just purely a technical process. It's not purely for the supply chain planners. The best people that are adopting this are integrating engineering into the process changes. They're integrating their procurement people into the process changes. And they're changing the incentive structures within the organization. So it's not purely buy at the lowest price or engineer to the highest standard so it never fails. It's understanding the full range of the supply chain and how these decisions can affect it so that the end state is they have a higher service level out to the end user of the equipment that they're building and supporting.
It's good. Dominic, what are some of the key principles to deploy an inventory optimization solution and improve service levels without increasing costs?
Yeah, that's a key question, because obviously putting such an inventory optimization engine in place with a company is nothing you do overnight. It's a journey, and what we like to really focus on are some key principles how you implement such a tool or such a technology. And it really starts very much hands-off from the technology itself. So the first step that we usually look at is really to deeply analyze the variety of inventories that a company has, be that cycle inventory, so things you consume as you go, be that ammunition, uniforms, food, or supplies, but certainly then also safety inventories that are needed to, safety inventories that are needed to ensure high service levels. So if you have breakdowns in mission critical situations, that the parts are as close as possible. So segmenting and analyzing the inventory is the first step. And the second step is still hands-off from the tool. How do you actually find the right balance between your inventory and your safety stock and your service level? And what we have seen over many of these journeys is it's a disproportional relationship between the two. So just because you pile up your inventory does not proportionally mean your service levels go up in a similar fashion. So finding that right balance between those two dimensions and really figuring out the technicalities is absolutely crucial. Now, what we don't have on the screen, but what I still think is our third principle when deploying this solution is to actually look at it multi-echelon, right? So traditionally, if you look 15 years back and when planning algorithms weren't as sophisticated as modern solutions are now, what you would do is you would optimize layer by layer of your supply chain. So you would optimize your DLA depots in Konus and have the right inventories there. Then you would go further out and you look into the different mission commands and go further out to the theaters and you analyze in which supply point, stage by stage, do I need to store how much inventory. What modern applications do is really a multi-echelon improvement, which means you look at your supply chain holistically, you look at the dependencies and interdependencies at the lead times between your supply points to write the right amount of inventory at each node in a network. Yeah? And that gets extremely complex because if you just look at the DLA and Army or Air Force infrastructure here in Konus and out in the world, you have hundreds and thousands of supply points in the network and connections between them where you can airlift, where you can truck them, where you can use ocean freight. So really optimizing that needs a very powerful engine. Yeah? And then the fourth and last principle is to focus on really what are the drivers of your inventory? What are the key, let me say, metrics that impact your inventory levels? And that's also what we then do very much hands-on on the tool, where we really calibrate, let me say, the mechanics of the tool, because at the end it's an algorithm, right? And an algorithm needs to be fed with the right information, such as what are your lead times between your network points, what are your supplier response times, right? So that's basically how we look at implementing such a solution.
You know, before we move on to the next topic, based upon what the gentlemen have already discussed, are there any questions?
Yeah.
Yeah, with the agile manufacturing, I'm curious as to how you're managing issues related to intellectual property and payment to the vendors who own those drawings and re-engineering. The other question I have is what analysis is done to look at the MIME solution relative to your sourcing engine and segmentation of inventory, reserving inventory for different platforms. The two are not compatible. Mm-hmm. So I'd just like to hear your answer on that. Thank you, sir.
So, with the additive and distributed manufacturing, one of the things that we've included in our solutions, and pretty much everybody out there has to, is some type of digital rights management software so that you give permission to the drawings for a certain period of time. They explode at a certain time when the document expires. It does require the legal element, so all legal counsel has to get involved. This is where the procurement folks have to get involved and change what they put in the procurement contracts. Certainly when you acquire the rights to the design, then it makes it a lot easier for you to resource. And that's one thing that DoD has a significant advantage of in a lot of different areas, is where you own the rights to many of the designs. Where you don't own the rights, it becomes a problem, because then being able to take that and resource it from supplier A to suppliers B, C, and D on a whim is not capable. And that's where you need to engage your procurement and your legal counsel in it and decide for certain parts, is it worth changing the underlying rights that we purchased to make this in an additive and distributed manner, or do I stick with the original supplier who owns that design element? But so there's a variety of technical solutions as well as legal and process solutions. The second question was, I think, from the mining perspective there, or?
No, in a sense, you have a sourcing engine that has business rules that defines who gets what based on priorities. Mm-hmm. But when you build a MIME solution, you're looking at total installs and efficiency,
Yep.
failure rates, and those things across the enterprise.
Yeah.
But then you segment your inventory and who gets it via your sourcing engine. So you have an optimal number, but now you're sub-optimizing things via your sourcing engine. And I'm just curious, what, if any, rationalization takes place before you implement that MIME solution?
I mean, it's a fantastic question because there's a natural, I would say, conflict of interest between procurement trying to strike the best deal and the responsibility of an inventory is to have the highest possible service level, and that's the conflict of interest you're describing right there. To us, the key is, first of all, integration. You need to have a clear integration between your procurement system and between an inventory optimization or management engine, because what we have seen a lot of commercial companies do is they try to basically segment depending on the urgency, for example, of a request. I'll give you an example. We have an airline customer, and if it's a part, let's say, from an OEM that is not critical to a production process, they have a supplier that is reliable, that is cheap, that is where procurement contracts are in place. But then for the same part, they essentially have other OEM contracts, which are just much faster in providing the parts. So they just differentiate based on the urgency of the part itself, whether they go fast track to supplier one or whether they follow the standard procurement guideline supplier 2, and therefore there needs to be a tight integration also with the order management system in between that governs that. Yeah.
I think one of the things you led into as well is the difference in forecasting philosophies between a historical forecasting that takes the past, looks at how you optimize that, statistically forecast forward, safety stocking to cover the variability, and then an engineered standards, a readiness-based forecasting model. Much of what we're talking about here is going beyond the initial readiness-based forecasting on an engineering standard, because those don't get updated necessarily. They don't also get updated to reflect current operational experience. If I built my expectation for an engineered standard for the part failure based on Northern European operations and I end up in Southwest Asia and I haven't updated those unless I do it every 10 years, I'm behind the curve consistently. And so most of what I'm seeing now is a shift to where I'm using past actual consumption data to forecast future, not so much the engineered standards that came initially with the sourcing of the program itself, potentially. In the back.
Yeah, so I love the concept of
Just throw the mic across the room. There we go.
Joe Kehoe with IBM, but I love the concept of additive manufacturing. Once you create a part, it then becomes integrated into your supply chain. From a warranty perspective, the creator of that part, are they now the OEM? And so if a part were to fail down the road, or as it's transitioned throughout its supply chain, do you go back to the creator to?
It's going to require a little bit of work with the procurement and legal communities to decide where do we put that? Do we put the onus on the designer of the part, on the printing service bureau that printed that part? Do we even care because we've created an emergency part that isn't really under warranty? It was an emergency part to get a piece of fielded equipment back up and running in a hurry. And so the legal procurement community is going to need to make that decision where they want to place the warranty on and who gets that. And it hasn't been answered, and there is no single way that everybody's deciding that. I think it breaks down in a couple different paths.
Yeah, I think that is a key point that Dan is mentioning, that obviously this is really an evolving field, right? There's no clear standard right answer or wrong answer yet. I think there are, three essential parties involved in that. There is first of all, the manufacturer of the printing devices, right? That itself is a huge technology, and we've seen printing companies innovating in that space and then working with the actual manufacturer of the parts that have the specifications. Then you have the parts manufacturer. Again, they form alliances with printing companies, and you have the consumer, which is you in that case, right? Or which would be the DoD. And I think this triangle yet needs to be firmed up, how that works. We have seen also businesses where actually the 3D printing company basically charges on a service level let me say, on behalf of the original parts manufacturer, right? So there are multiple scenarios how that can end up.
Team, so in a more connected world, we're seeing people companies and organizations connect directly with each other in real time. Dan, how do you see the military taking advantage of this to connect their entire supply chain and get everyone on the same page in real time?
I think one of the things that has to happen if you want to take out the inefficiencies in the supply chain is to create greater transparency and visibility. Speaking as a maintenance guy, a former unit commander, and I know the statute of limitations is probably over, a holder of DLRs under my bunk in the ship to the tune of maybe $1 million or $2 million. Everybody does it out there. We hoard these parts because we don't trust that it's actually going to get delivered. I don't know where it is. I don't know when it's going to get to me. I have no confidence at all in the system. And so creating some type of visibility is paramount to actually being able to do the changes where I reduce the inventories. I have to change a little bit of that command culture. So when I'm in command, everything in my unit, that's mine, and I'm not letting anybody get my hands on it, even if somebody actually owns it. So possession is 11/10 of the law in the military. And if it's on my base and in my compound, I own it, even if somebody else paid for it with AUKUF funds, right? We kind of are fighting that. And so if we create a visibility solution that looks somewhat like this, where I can actually pull it up, I can see on a map where things are moving, I can see the delivery accuracy so I know who my problem child is. And there's a basic assumption that people understand red is bad, green is good. If you don't have that and your people have issues there, we have a different training problem to solve. But starting with that assumption, you can look at these kind of dashboards that meld information from a variety of different places so that people can see things in motion. And what we're doing now at Transcom with the Phase 1.1 is a significant effort in that direction, and then tying it in later with DLA and across the department will enable us to provide these solutions so that we get a level of trust back in the organization so that people will see this stuff coming and they'll know that it's next door, and if I give up this part for a fellow unit, I'll have a chance of getting something back in my house. But it is a long road for us because we have, I'd say, 200 years plus of hoarding mentality inside of the military to make sure that I have everything I possibly need and I'm taking it all with me when I go on deployment. And so we have to overcome that with things like this where I can see where my things are. I can take the IoT sensors and see shock level and temperature and tilt. And I can drop them on an exception dashboard so that I can see when things are coming in electronically. I've got a signal, and it's not a phone call from a supplier. It's not a carrier that's telling me that it's going to come in, but we know that they're always wrong. And so we use predictive algorithms to apply to our ocean freight shipment, and we're working with startups that we've invested in to do that, where they can tell you that I know that a particular shipping line out of a particular port is always 30% wrong, and stuff like that.
Yeah, Dominic, please jump in.
Yeah.
Yeah, thank you very much. So, I mean, you saw a little bit our journey now. We moved from how do you optimize your inventories, how can you manufacture closer to the source, and now we're right in the execution where the real action happens in the supply chain, where actually the things are on the road. And what we've seen a lot is, especially when you look at the visibility part that Dan described, the key element that brings value to companies or to the DoD will be how do you use this information to really take decisions, right? That's what it boils down to. Having the information in a consolidated way, having high accuracy of the information is crucial. And then what we work a lot with different customers is how do you then take precise decisions, right? For example, depending on the urgency of your shipment, you might decide to use a certain modality or a certain route through your network. So a decision that you would take if you see that there's a delay is you could reroute your shipment. You could change the modality. You could pre-inform whoever is the receiver of that shipment. Yeah? So those are some of the key, let me say, decision points that are enabled if you have a global tracking and traceability engine.
And I think what you guys did with Complete up in Europe is significant because it's helped push the window back in the day. You want to talk a little about that?
Yeah, very good point. So what you see here on the screen is an example of a commercial, let me say, Amazon competitor. It's not Amazon, but they're a leader in the Nordics in Europe for electronic goods. So if you buy your cameras, even batteries, any type of electronic devices, basically, these are an e-commerce shop. And what we want to show you here is how aggressive their supply chain works and what is, let me say, some of the key enablers for such an aggressive supply chain. So what you can see here is that basically they do next day order fulfillment. So that means by 9:30 p.m., so once we're all at home tonight at 9:30 and we have an urgent need for something tomorrow, by 9:30 p.m. you can get an order in, and by the next day you have it in front of your doorstep. Yeah? So how that works is really with the interplay of, first of all, your order management system, where the order is captured, be that online or in whatever shape or form. But there's a big complexity. First of all, you need to know, again, do I have that in stock? Do I have that inventory available? And then immediately you also have to check, do I have, and that's the segue into transportation, do I have transportation capacity to get it there the next day? Where is it needed? So that interplay happens basically with submission of the order. What happens then is overnight, a lot of things are happening for these companies overnight, unfortunately, but come after a few adjustments, come midnight, they start with transportation management, a planning run. Right? So we heard the conversation from Transcom earlier, you call it the strategic lag. So what our transportation management system of SAP does is basically to plan, how do I get it to where it needs to be in the most efficient way? But I'm also immediately ordering supply if I realize my inventory is not in stock. So that all happens basically in that midnight planning window. And here comes the segue to the nice presentation from DLA, the warehouse. Now you have planned your transportation, you have either the goods in stock or you have just ordered them, but now you have to physically get it executed in the warehouse. So come 1:30 a.m. at night, when the transportation is planned, we basically release to the warehouse to start the picking, packing, staging for the first truck, leaving at 6:30 a.m. in the morning, right? And this handshake between the order management system, between a transportation management system and a warehouse management system is really absolutely instrumental to achieve such an aggressive supply chain. Because each one of those systems has key intel that is interdependent to the other system. I'll give you an example. A transportation management system can never efficiently plan and optimize capacities in a truck, in a ULD, or in a container without knowing how the things are going to be palletized. That's what the warehouse knows. So therefore, the interplay between a warehouse of how I'm going to pick and package the goods and the transportation management system planning the transportation, that is really the key part that we advocate and that we emphasize. Amazon built actually their own proprietary software just to solve that huge problem that SAP does with the interplay of those three applications.
Hey, Dominic, I just want to make sure we take a look at how potentially DoD can adopt some of this commercial innovation to improve order fulfillment as well.
Mm-hmm. Yeah, fantastic question. I mean, we had today fantastic groups already up here on the stage. Before us, we saw our partner Telesto, who is doing the Transcom implementation, who basically already started the journey of implementing, I think it was called the Prime Transportation Management System. The integration, of course, with DLA to make sure those departments are closely aligned, having a warehouse management system in place. I think that's the start of the journey, right? I mean, and also we heard the term earlier of an MVP, a minimal viable product. We love that term because that's what a lot of companies really don't do right, that they start with a foundation or a platform. And obviously changing such processes where you also have a mix of very proprietary secret information that cannot simply be exchanged like a commercial company does. You have to start with a foundation. You have to start small with a minimal viable product and then expand, further integrate from there. And that's also what I encourage all of you to do, is really to look across the borders of your departments, because that's where you can achieve incredible synergies.
Dan?
Yeah. I mean, one of the things we're seeing is there's a lot of examples from commercial integration. It's the pace of the rollout, too. A lot of the rollouts get stalled, and they take forever, so you don't start to achieve benefits, and then the organization gets tired. And you have to increase the pace of the rollout. So I think methods through agile development that we're seeing and the minimum viable product are things that have happened. There's an aviation parts company that was going to speak here today, unfortunately couldn't make it. They rolled out to 72 sites on a global basis, distributing aircraft parts to keep aircraft off the ground. And so they got that rollout out there by doing phases. Their phases went over the course of 4 years, where they did initial phases with basic functionality, and then they've gone into a more advanced functionality of parts kitting and the integration back into a variety of transportation systems. So the key here is break it down into smaller chunks and then move out, and that's what I'm seeing in the commercial side as well.
So gentlemen, before I go back out for last bit of questions, any final thoughts?
Yeah. I think one of the things we're doing on the SAP side is how do we do technology investments to make all the efficiencies happen inside the facility, to make things work in a more automated fashion. And one of the things that was fascinating to me is we're working with a company that has built a vision system so you can fly drones around the warehouse and do the scanning and take out the tasks like physical inventory count that don't normally happen and then integrate them in while the warehouse is open. So I don't need to shut down and I can fly it around. And their test with me as I went to their warehouse and they had me stand in the aisle and they flew the drone straight at me and said, don't move. I know you're not in the map, but it won't hit you. And I'm like, okay, I guess my career is worth it. And they flew it at me and it picks up things in the warehouse so you can operate in a heterogeneous environment. It's how do we digitize the paperwork so I don't have to go old school 20th century with a piece of paper following everything around, but I can have a validated, authenticated piece of paperwork that's digitally moving around the world. And so I don't lose things. So my self-propelled howitzers don't sit at the German border trying to get back in from Poland because I didn't have the right paperwork to clear customs. That actually did happen earlier this year. So things like that, I think we're making the investments in digitization. What we need is our customers to make an investment in the process changes to take advantage of that digitization, just like we're doing ourselves at SAP.
Dominic?
Thank you. Final thought from my side is there's a lot of innovation out there. There has been strong adoption of some of those technologies in the commercial space, and I think the DoD has tremendous potential in adopting it in a defense environment. What I would like to offer is, in my opinion, seeing is believing. So if you are interested in some of these innovations that we spoke about today, if you want to learn more, discuss deeper, we always work very closely with Dan and the team from SAP. So please feel free to approach us. We have a little demo pod outside on a little table on the side. We've got pretty much everything I talked about today on the screen. So if you just want to see a little bit how commercial companies have adopted that, we also have a DoD-specific use case and example. Please do approach us and meet the team.
All right. Questions? Is there any other final questions out there? I think we have.
Sorry, I'm going to ask the medical question again. From the additive manufacturing conversation, I could see a lot of use for DoD for additive manufacturing within medical products. From an industry perspective, have you seen any movement toward that direction? And if so, how do they get over the FDA requirements?
Yeah, we've got a lot of the life sciences companies that are working on this for a variety of parts because the supply chain they're operating in expects 100% availability for surgical kits, stents, whatever devices that are up there. The biggest thing is early adoption and integration with the engineering community, the product side of their organization, to get past the FDA validation. So if they started it as a supply chain project, it doesn't go anywhere. When they started as an engineering project, it seems to go a lot better.
All right, team, I think
there was
we've
one right
actually-
here in the front.
Okay.
He's been waiting patiently.
Okay.
Could this be applied in reverse where the DoD is? Thank you. Could this be applied in reverse where the DoD is responding to international humanitarian assistance and disaster relief operations, or a warfighter in a FOB, where they scan with a mobile device supplies and then use some sort of a telemetrics in a remote location, austere environment to place order and then work this in reverse to get those supplies out in those odd environments?
Yeah, I think so. I mean, one of the things, one of my activations, I was a logistics JPT lead for the Ebola task force up at AFRICOM, and our challenge was getting the demand signal from out in the field. And so what we did with the help of DLA, which I know upset a bunch of Transcom folks, we chartered a ship in Europe, filled it with a bunch of stuff that we didn't know, and just sent it forward to get there. But getting that demand signal back, we didn't adequately take advantage of the infrastructure that existed there. There's a cell phone network, and I know that SAP has created agricultural solutions for rural areas so that we can connect farmers to the market. That same type of solution would work in a DoD environment where I'm using a very low bandwidth requirement to get information back in so I understand the true demand picture instead of trying to guess at it and just throw billions of supplies that then, it's always in the back of the last container that arrives is what I really needed. So I think there's a lot of opportunity to do with these little apps in the SAP Cloud Platform type app to connect out into the field, get a better demand picture in real time, and then have that stuff move forward, not clogging the arteries with everything. Not that ever happens inside DoD.
So I think we've exceeded our time a little bit, but if you have any other questions, please address Dan, Dominic, either during lunch or thereafter, and please don't forget about the demonstration table that they have outside. Thank you.